Hi there. Now for this question, we're told that the volume v centimetre cubes of a box of height x centimetres is given by v equals 4x multiplied by 5 minus x squared for values of x that are greater than 0 but less than 5. And in the first part we've got to find dv by dx for 4 marks. So if you'd like to have a go at this, haven't done so already, just give you a moment then to pause the video. Okay, welcome back then if you had a go. So for the first part then, part A, to find the value of dv by dx, if we take v equals 4x multiplied by 5 minus x all squared, it's not in a form ready for differentiating. So what I'm going to do is have to expand this. So we've got 4x multiplied by 5 minus x times another 5 minus x. And if you square the bracket out, what you get is the first term squared, which is 25. You get twice the product. The product is minus 5x, so if we double that, that would be minus 10x. And then we get the last term squared. So minus x, if you square it, gives us plus x squared. And now we expand again, multiply through by 4x, so you're going to get 100x, and then minus 40x squared, and then plus 4x cubed. Now we're in a position to differentiate this, and so we can find dv by dx. And if we differentiate this with respect to x, the first term just goes to 100. As to the next term, 2 40s are 80, we get minus 80, reduce the power by 1 and you get x. Then we get plus 4 3s are 12, reduce the power on the x by 1 and you get 12x squared. Okay, so there we go, there's part A. Now in the second part, okay, part B, what have we got to do? Well, it says, hence find the maximum volume of the box for 4 marks. So again, if you'd like to have a go at this, just give you a moment to pause the video. Okay, welcome back if you had a go. Now, remember that when you're finding a maximum or even a minimum point on any graph, just remind you just here, in case you're unsure, if you've got a maximum, which is this point here, or even a minimum point, that point there, we know or should know that the gradient of the tangent is always equal to 0. And that means that in this case, dv by dx, which gives the gradient at any point on the curve, must equal 0. So we're just going to put here that at a stationary point, okay, and I'd always encourage you to do this when you're answering questions like this, at a stationary point, in this particular example, dv by dx equals 0. So that means that therefore our quadratic expression here, 100 minus 80x plus 12x squared, must equal 0. So now we've got a quadratic equation, and I notice that each of the terms here is divisible by 4. So I'm going to divide throughout by 4, and I'm also going to rearrange it. I like to have the x squared term first of all. So if I divide 12x squared by 4, I'm going to get 3x squared. Then we'll follow that with the x term. Dividing minus 80x by 4 gives me minus 20x. And now we've got the 100, divide that by 4 and you've got plus 25. And obviously 0 divided by 4 gives us 0. Now I could solve this quadratic by using the quadratic formula, but this one factorizes, so I'm going to factorize it. We're going to have 2 factors, okay, and that's going to equal 0. And in here we'll have 3x and x, that multiplies together to give us 3x squared. and then two numbers for 25. That's going to be -5 and -5. I can see that we're going to get minus 15x here, minus another 5x is the minus 20x. Okay, at this stage we should now be familiar with the fact that each of those factors should equal 0. So we've got 3x minus 5 equals 0, or the other factor, x minus 5 equals 0. And from this one, if we rearrange it for x, add 5, that's 3x equals 5, divide by 3 to both sides, and x equals 5/3. Or when x minus 5 equals 0, adding 5 to both sides gives us x equals 5. Now x has to lie between 0 and 5, we're told. Obviously it can't equal 5 because 5 take away 5 would give us 0, and the volume would end up being 0. So we'll just say therefore x doesn't equal 5, as v would equal 0. So we're just looking to find out then the value of v when x equals 5/3. And so therefore if you were to substitute this in to our equation for v up here, we'd find that v equals 4 multiplied by 5/3, then multiplied by 5 minus 5/3, all squared. And what you get, if you work this out, is 2000 over 27. And that'll be measured in centimetre cubes. Okay? Right, so we're now on the last part then, part C. And for part C, it says use calculus to justify that the volume that you have found in part B is a maximum for 2 marks. So again, if you'd like to have a go at this, just give you a moment to pause the video. Okay, welcome back then, if you had a go. Now for part C, if we're to use calculus to show that something is a maximum, a point like this one here, then we have to do the second differential. In other words, work out what d2v by dx squared is. And then we substitute when x equals 5/3 into the second differential, and if it comes out as negative, then it indicates a maximum. So that's how I'm going to approach this. Okay, and if you're unsure of the second differential and this test, do check out the video tutorials on my website. So what we've got then is the second differential, d squared v by dx squared. So if we differentiate dv by dx with respect to x again, the 100 goes to 0 when we differentiate it, minus 80x goes to minus 80, and then we've got to differentiate 12x squared with respect to x, and that's going to give us 24x, so plus 24x. Now we just need to substitute when x equals 5/3, and if we do that, we end up with d2v by dx squared equaling, and we've got minus 80, and then you've got plus 24 multiplied by 5/3. Hope you can see that, it's a bit squashed there. And if you work that out, you end up with minus 40, a negative number, its value is less than 0. So therefore what we've got is that this is a maximum. Okay, so we've been able to use calculus then to show that this was a maximum. All right.